Now write down to your notes from this slide about flexible automatic lines and flexible production system, FPS, and flexible production module. So almost all from this slide, write down to your notes. In this slide, you can see an example of the flexible manufacturing system. It consists from robots, robot 1, 2, 3, and 4, assembly station, AS, machine M1 and machine M2, conveyors, conveyor 1, conveyor 2, and painting station, and then output buffer. All these items include the flexible manufacturing system. Another example of the flexible manufacturing system. You can see robot portal type of robot, CNC machines, and computer. An example of FPM, flexible FPM, flexible production module, is a production model shown in figure 12.5. Figure 12.5, position 1, loading robot. Position 2, CNC device or CNC machine. Position 3, chip straining device. Position 4, part storage, and position 5, tool storage. So the module is a semi-automatic lathe designed for processing workpieces of parts such as bodies of revolution according to the control program set through a numerical program device 2 equipped with a loading robot 1, a chip removal device 3, a part storage 4, and tool storage 5. The machine is equipped with tool condition monitoring devices during processing and its automatic replacement. The model can be built into a flexible line or section. You can see in this slide an example of flexible production module, FPM. Another flexible production module with CNC system, machine tool with CNC system. And now we start 12.4, industrial robots and their types. Write down to your notes 12.4 Industrial robots and their types. A robot is a mechanical system with manipulation devices, a control system, a complex of sensitive elements, and means of movement in space. Write down to your notes definition of a robot. What is a robot? Robots implement the idea of functional modeling of production, workers employed in various technological operations of the production process. An industrial robot. We use in in mechanical engineering only industrial robots. An industrial robot is a reprogrammable manipulator that can automatically perform a set of actions provided by the program. Write down to your notes definitions of industrial robot. In general, an industrial robot includes the following main elements: manipulation devices, control system, sensor, elements, and vehicles. Manipulation devices of the robot are executive bodies that in time, write down to your notes all these elements of the robot, manipulator. Manipulation devices of the robot are executive bodies that imitate the action of human hands on a natural scale with any increase of or decrease as well as power effort. The control system. It was manipulation device. Now control system. The control system with or without a computer can have several levels similar to different degrees of the human nervous system and brain. The next element of industrial robot is sensor elements. Sensing elements or sensors of the robot give the necessary signals to the control system about the approach of the hand to object, about touch, etc. These elements allow the robot to orient itself in the right way to achieve a certain goal in the environment where it operates. Please write down to your notes the sentences about robot, industrial robots, and main elements of industrial robots.
Teacher, your mic is off.
Oh, thank you. Excuse me. So I repeat one more time. The means of movement of the robot can be any depending on its purpose. Walking mechanism, devices on wheels, caterpillar devices, a combination of all three methods. A robot is a multi-purpose machine and differs from a conventional machine in its flexibility and versatility in performing various operations. According to the method of control, robots are divided into three groups. Write down to your notes these three groups of robots with manual, automatic, and combined control. The term industrial robot usually refers to manipulators with automatic or combined control. The use of industrial robots is characterized by the fact that long terms of implementation are not required. No large expenses are required when transferring an industrial robot from one job to another. Provides low cost of debugging the robot. Existing works can be divided into three classes. And write down to your notes these three classes of existing works. Humanoid, information, it's Earth satellites, like Earth satellites, and industrial robots. In terms of their capabilities, industrial work belongs to the next three generations. So write down to your notes these sentences, this part of the slide, three classes of existing works. The first generation is a manipulator with a software control device. Write down to your notes the first, the second, and the third generation of robots. Manipulator. The second generation is works with feeling, with feedback. The executive hands of the work are supplied with various sensors that provide information about the state of the hands and objects with which he must manipulate, as well as about the main properties of the environment where the process takes place. Such sensors can be contact sensors that signal the touch of a hand on objects, locational, determining the speed of movement and distance to objects, television and optical, creating artificial vision, as well as sensors that distinguish color, warmth, sound, etc. It's all about second generation robots with feedback, with feeling. And the third generation is work with artificial intelligence. Run down to your notes 3 generation of manipulator. The designs of industrial robots are classified according to the following criteria. Purpose, universal and special. The nature of the movement of the hand, moving along cylindrical and spherical surfaces. Type of motion drivers. Type of motion drivers: hydraulic, pneumatic, electric, and mixed. Hydraulic with electric, or pneumatic with electric, or hydraulic with pneumatic. Mixed. Type of movement of the robot: motionless, floor and suspended, and floor mobile, suspended mobile. Placement of the control panel. Placement of the control panel. A separate control panel and a remote control on the robot. Design of the control panel. The program is set by the panel with a plug-in set computer control. Technical capabilities. Mass of parts to be lifted and size of operating of grippers. Amount of lift and extension of the gripper. According to the production and technological futures, industrial robots can be divided into groups. Production, no more than 20% of the global park, and lifting and transport. The first group includes industrial robots that are directly involved in the technological process as manufacturing or processing machines, welding, painting, etc. So write down to your notes. No. From. This first part of the slide and the second part of the slide. Classification of robots, industrial robots, and that industrial robots can be divided into groups. In the figure 12.6, you can see a robot manipulator. First, position number 1, it's stand. Position 2, horizontal movement drive. Horizontal movement drive. 3, vertical displacement drive. It's vertical displacement drive. 4, drive of angular displacement. Rotation. Rotation, angular displacement. And 5, capture. It's capture. Handling robots are designed to automate and loading and unloading of parts and tool change on metal cutting machines with an automatic part processing cycle. An example of such an industrial CNC operation is shown in figure 12.6. The robot consists of a massive base 1, massive base 1, horizontal movement drive 2, vertical movement drive 3, angular movement drive 4, and gripper or capture 5. Capture 5. The robot works in 3 modes: training, repetition, editing. It can serve 1 or 2 machines, forming a machine industrial robot system with them. The most effective use of industrial robots is in conditions of multi-product production, which requires frequent changes in manufactured products and corresponding change in the technological process and equipment readjustment. Under these conditions, the universal characteristics of robots are used to a greater extent. In this slide, you can see the examples of handling robots. Can you the questions about robots and about industrial robots? Okay, if you have the questions, we start item, the last item of our lecture, 12.5, process development automation. Process development automation. We can make, before we start this item, we can make a 5 minutes break. It's time for 5 minutes break. Have a rest, please. So we can start item 12.5, process development automation. The problem of automating the development of technological processes lies in the presence of uncertainty in the relationship between the quality indicators of the product the parameters of the manufacturing modes, the state of technological systems, as well as the imperfection of the methodology for developing processes, the low level of its formalization, the multivariance of technological solutions to the same task. For example, with the same workpiece processing modes on machines of the same model, the processing accuracy will be different since the machines are in a different state which is not fixed anywhere. Other examples are the choice of technological basis in the development of technological processes, carried out not in accordance with a strictly formalized methodology, but according to a number of recommendations. All this does not completely exclude human participation in the development of technological processes. In computer-aided design, the designer must solve creative problems, and the computer must solve problems whose functions are mainly related to the implementation of non-creative or mental formal processes during design. Further development of the theory of design and computer technology allows the gradual use of computer technology to solve creative problems. So write down to your notes this part of the slide. These sentences. In computer-aided design, the designer must solve creative problems, and the computer must solve problems whose functions are mainly related to the implementation of non-creative or mental formal processes during design. However, this is possible by eliminating the uncertainty of the problem statement, improving the methodology for developing technological processes, and increasing the level of its formalization. Therefore, the solution of the problem of automating the development of technological process should begin with the formalization of the methodology for their development. Please, these sentences write down to your notes. With the current state of the methodology for developing technological actions, depending on the specific conditions, several levels of design are designated. The development of a process flow diagram, the design of a technological road for processing a part, the design of technological operations, the development of control programs for equipment with numerical control. its important levels of design and designation. With an automated solution of the problem, the interactions of the technologist designer with the computer represents the process of information exchange in a certain mode. There are two main modes: batch, automatic, and interactive operational. In batch mode, the technologist user and the programmer, as a rule, do not have a direct connection with the computer. The text of the programs, the results of their verification, and the solution of the technological problem are transmitted through the computer operator. An application software package is a complex of programs and is designed to solve a certain class of technological problems that are close to each other. For example, designing a technological road for processing parts of a certain class, assembling units, and assembly operation of a given type. So write down to your notes this and this part of the slide. We talked about batch mode, and now the dialogue mode. Dialogue mode is effective in solving creative problems when a heuristic approach is needed. Recognition of geometric images of parts, dimensional and topological relationship between elementary geometric images in order to optimally select basing schemes, design a processing road, assembly, etc. At the same time, in the interactive mode, the costs of creating software increase significantly, and the costs of design increase. You can create software package that allow you to accumulate design experience and form classification, algorithms, concept generation, behavior. Therefore, the problem arose and is being solved of creating automated systems for the design of technological process, CAD-TP, system of automatic design of technological process, TP, in a dialogue mode with a subsequent transition to a batch automatic mode of a higher level by using training programs. CAD-TP has subsequent support for computer-aided design. And write down to your notes all these types of support. First type of support is methodological support. Methodological support. A set of documents that establish the composition and rules for the selection and operation of design support tools necessary for the implementation of computer-aided design. Next type of support, information support. Information support, a set of information necessary for the design presented in a given form. The third type of support, mathematical support. Mathematical support is a set of mathematical methods, models, and algorithms required for design presence in a given form. Linguistic support is a set of design languages, including terms and definitions, natural language formalization rules, and methods for compressing and expanding text required for design presented in a given form. Next type of support is software. Software is a set of computer programs necessary for design presented in a given form. The software is divided in two parts. General software, its operating system, necessary for the operation of the computer. And second, it's special software, including all programs for solving specific design problems. Next type of support, technical support. A set of interconnected and interacting technical means intended for design. And the last, it's organizational support. A set of documents and establish the composition of the design organization and its divisions, the links between them, their functions, as well as the form of presenting the design results, and the procedure for reviewing the design documents necessary for the design. So write down to your notes all types of support of CAT-TP. CAT of technological process. And the last slide of our lecture. Many of these listed types of support require the development of database and, as a result, the development of knowledge bases. Analysis of various CAT-TP shows the following. The task solved in the development of single technological processes for the manufacture of parts based on analogous processes are formalizable, which is reflected in the creation of a significant number of computer-aided design systems for technological processes using the principle of standard solutions. These systems can be considered as separate software modules that can be part of automated systems for technological preparation of productions. The most difficult formalized task which is solved when developing single technological processes for manufacturing parts is the choice of technological basis and the creation of road technology, the development of which requires the synthesis of the structure of the road technological process, determines the composition and sequence of technological operations. In the mathematical setting, this problem is reduced to finding variants of structures in countable sets with a very significant, albeit limited, number of parts. The tasks solved in the development of operating technology are easier to formalize. So it was the last slide of our lecture. If you need time to make a conspect for this slide, do it. You have about 4 minutes before our lecture will finish. Who finished make the conspect of the slide can be free for today. Have you questions, students?
No, teacher, thank you.
No, teacher.
Okay, have we any in the next week, have we the lecture or practical lesson, or this is the last lesson?
No, we don't have. This is the last.
Okay,